Welcome to Heavy Networking, where we've been documenting, describing, and deep diving on the technologies, tools, and trends found in the wonderful world of networks for well over a decade now. And if you know your frame from your packet from your datagram, you've found your tribe. I'm your smiling co-host, Ethan Banks, with you since 2010. Drew Conry Murray is in his customary trusted place, sharing microphone duties. We ask the questions and seek explanations that help you make sense of what's going on in networking. Today, we discuss how Agentic AI, artificially intelligent agents, bots of a sort, can be delegated to in a trustworthy manner. AI for network operations. Joining us for this discussion is Juniper Network's Bob Friday. Bob is the Chief AI Officer at Juniper, now HPE, I guess, and we will explain what AI agents can and can't do and how you're going to implement them in your network. Or you won't, but Bob thinks you will. So Bob Friday, welcome to Heavy Networking. And Bob, your title is Chief AI Officer. Does that mean you yourself are an AI? Can you even be sure one way or the other, Bob?
Well, let me tell you, anything that makes me look younger and gives me hair is all good. So I'll take it.
Okay. All right, Bob. So let's kick off this conversation by talking about Agentic AI. By way of definition, now we've been talking about Agentic AI on Heavy Networking for a while now. It's come up in a number of our conversations, but we want to get Juniper's take on this. Define Agentic AI.
Yeah, for me personally, what I always tell people is that, AI is really kind of this next step in kind of the evolution of automation. The only thing different here is we're really automating things that typically have taken, cognitive, abilities of a human, right? Like that self-driving Waymo Uber. Now, what I usually tell people about agentic AI is, how do you ever know if it's agentic AI under the hood, right? You as an IT person, how would you ever know that, or anyone? And the four questions I always tell them to look at is look at Andrew Ng, right? If you look at Andrew Ng, the four attributes of agentic AI that he highlights is really around this graph of agents. When you say the word agentic AI, we're usually talking about a graph of agents. And I usually tell people that for me, agentic AI is really just a new nonlinear, non-deterministic programming language that we're going to use to automate things. And that multi-graph thing is the nonlinear piece. We're building graphs of agents that are connected, and that's the nonlinear piece. This thing can go from agent to agent in this graph. The non-deterministic piece is that these agents are actually starting to use these large language models. And that's a non-deterministic piece. The other thing Andrew Ng will point out is these characteristic of these agentic AI is reflection. That people are starting to use these agents to actually check their answer, right? And that's probably the other key component of these agentic AI is, do they have reflection built in? Are they actually trying to see if their answer is actually correct? And probably the other key component he talks about is tool use, right? We're basically giving these agents tools to actually solve problems. And when they say tools, we're talking about APIs and function calls, letting these agents decide which function APIs used to solve a problem. And probably the biggest thing is this concept of planning and reasoning, right? This is where we're taking these large complex tasks and we're letting the LLM start to break these complex tasks down to smaller tasks. So that's kind of a long answer to a short question of, what is agentic AI versus just AI?
So can you drill into a little bit more on what you mean by a graph of agents? Because I could understand sort of like a pool of agents or a group of agents, but a graph of agents, what does that mean?
Yeah, I mean, so for people who are like building these new agentic frameworks, they're usually using what LangGraph or Crew AI. And what you're really doing is you're defining a graph. And when you actually program these things, you're defining the start of the graph and the exit of the graph. And then you're putting agents on this graph and you're defining the edges. You're basically telling if you look at LangGraph, right, that's really the orchestrator. You're basically telling it, what agents can call other agents. And usually if you look inside the code of these things, you'll find out that, they'll put limits on it. Like, hey, you can only go back and forth 5 times, so you don't run your Amazon bill crazy, right? Because, we're talking, we're starting to talk real tokens. We're trying to talk, this is not your one-shot deal. We're trying to talk real tokens now.
Okay. So this means there's sort of, don't know if space is the right word, but we're talking about you're setting up some boundaries where information is coming in and an action is coming out, and there are boundaries in between those two things happening. Is that what we mean by graph? Or
Well, you think of a graph, right? You think of a graph with nodes and edges. Now, each node on that graph is going to be an agent. And then you go, well, what's an agent, right? And if you look at when they say the word agent, they're usually talking about it's a piece of code that's creating a prompt
Mhm.
to call a large language model. Now, how that prompt gets created is usually with a whole bunch of API calls.
Mhm.
You're basically trying to create a context, some context for answering a complex task, whether you're trying to book a ticket on a plane or in my case, I'm trying to troubleshoot networks, right?
Mhm.
And so you got complex queries, why is this Zoom call bad? If we had a problem here. And so that's the beginnings of creating these agents of graphs. And typically each agent will have a special task, right?
Mhm.
Basically you can almost think of like solving a problem where you have specialists, real human specialists. You start to think of the agents as a specialist in the graph. And you have all these different specialists that are optimizing for doing some task.
So in like a hospital ER, I've got my orthopedic surgeon, I've got my neurosurgeon, I've got my internal medicine person. They're all good at things, but they also need to leverage a larger body of knowledge to get information about what's happening and how their specialty is applied.
Yeah. And so you think about it, and I usually tell people to think about this as you know, so I make a barrel of wine every year, right? And I usually tell people, great wine starts with great grapes, great AI starts with great data.
Mhm.
And you think about where the data comes from. Usually when you're trying to answer a question, the data is in some database somewhere, or it's in some API.
Mhm.
Mhm.
And so typically, depending if you're asking a sales, if you're asking some question about sales, you're going to find the data is in Salesforce. Um, if you're asking some question about engineering, you're going to find out the data is in Confluence or Jira, right? So that is where these agents are almost being tied to the different data sources. Depending on if I'm troubleshooting a network, the data may be in some sort of support database,
Mhm.
or the data may be into a real-time networking database. And you can kind of think of, I don't know, I'm sure you guys have heard of MCP now by now, right?
Yeah,
Oh
the
yeah.
model context protocol.
Yeah, yeah. And so we're going to start to see, you know, we've all been trained on APIs, right? In the network industry, we've been writing, automating scripts and everything on top of APIs. You kind of see these agents are going to be written on top of MCP. We're going to be optimizing our historical API calls and starting to optimize these things for agents,
Mhm.
right? Because the agent needs a little, when you deal with these large language models, you need a little bit more information, description about the API that you're using to give the LLM some help on calling that API.
You said graph of agents, and we've just been talking through that. Another piece you said was nonlinear, non-deterministic programming language, the way you described it. And because there are LLMs tied on the back end. So just like we expanded on what we mean by graph of agents, talk through the nonlinear, non-deterministic components.
Yeah, I mean, so usually when we start talking about large language models and stuff, you always hear the word hallucination.
Mhm.
Yeah.
And that's kind of the non-deterministic part. And usually I tell people, I mean, I don't know if you have kids or if you've hired new employees, it's like, how often do your kids or your new employees do something that you go, what the heck were you thinking? You know, so that's what I call the equivalent of hallucination. Now, I don't know, have either one of you guys tried the self-driving Waymo Uber thing yet?
I've seen them, haven't gotten in one yet.
I mean, so that's the next piece of the puzzle. Okay, would you call that AI? A car that, self-driving car, does that qualify as an example of AI?
I guess I'd say it's more machine learning and machine vision, but I don't know how I'd slice that really.
Yeah, but this I'm saying when you get in that self-driving Waymo Uber, you're trusting that
Yes.
car to get you from A to B.
Hmm.
Yeah.
And that level of trust, when you do it, somehow you trust that that car was going to be as safe or safer than a human driver.
Hmm.
And I think we're going through that same exercise around these agentic AI agents. Do I trust this agent as much as I would trust my new employee?
Hmm.
right? And that's kind of where we are with this agentic AI when we're building solutions that are trying to do things on par, you know, with an entry level human, right? We're trying to automate tasks that normally I would have expected some human to take care of, whether it's troubleshooting a network or diagnosing cancer or doing something of that nature.
Another piece you talked about was planning and reasoning, which I twitched a little bit because LLMs don't plan or reason in the way that we as humans do, and yet those terms are applied. So can you explain, articulate what we really mean in this context when we're talking about planning and reasoning?
Well, I think, most people who've played with ChatGPT are starting to realize these LLMs are doing some level of reasoning. We don't quite understand how they're doing it. Now, in the case of agentic AI for these complex problems, they're actually using the LLMs to actually do some level of reasoning. Like, if I'm troubleshooting a network, I may have one agent dedicated to coming up with a troubleshooting plan, right? And that agent, I'll describe the problem or something, and that agent will describe the troubleshooting flow that, you would typically expect a human to do. And so that's the reasoning part of, you're starting to leverage these LLMs for a certain level of reasoning. And the large language model guys, right? Google, OpenAI, Microsoft, these guys are all building models that are kind of optimized for solving reasoning problems. GPT 4.0, Gemini 3.5, Claude. These models are starting to get better and better at doing reasoning skills.
So when we apply that to network engineering, and this is where I think a lot of engineers raise a flag. We're concerned about hallucinations, but you make a valid point that, well, humans make mistakes too, and so we're looking for the agent in this case to be as good or better than a human. And then when it comes to reasoning, there's got to be a model, there's got to be data sitting behind that that is going to allow the agent to come up with the sorts of responses to given situations that we'd be looking for, as a network engineer. Is that, are we there now, Bob?
We are there. I mean, I think, what I tell people now after working on this for, the last 10 years, trying to build self-driving networks in my space, I think agentic AI is going to be the catalyst for actually getting to that self-driving automation part of it. The reasoning part is actually coming. A lot of these large language models are doing some of the reasoning function. What we have to do is get it the right data. And I think the APIs, now I always tell people, if you get the wrong answer, it's either the data science or the data, right? Either you can work on the data. And what you find out is the APIs are pretty good. We've done a pretty good job of building APIs over the years, for our customers to automate on top of.
Mhm.
For these agents, what we're starting to do is, I don't know if you guys have heard of Open API.
Mhm.
This is a standard basically to help describe these APIs.
Mm-hmm.
Right. And so we're doing a much better job, and that's kind of where that MCP comes in at describing what the API does. Now, I would tell you the other thing that the Gen AI, Agentic AI, it put a big bright light on documentation, right? I mean, documentation has been the orphan in most companies, right?
Mhm.
Most documentation just sucks. If you listen to customers, guys, what you find out is, when you start to try to build an agentic AI solution that is, dependent on your technical docs or your white papers, those papers better be correct now, right? They better not
Right.
just be marketing fluff, because if we're going to build solutions leveraging those documentations, they have to be accurate and complete. And so I would say that's the other thing we're finding building these solutions is the APIs have to be solid. You have to get, they have to give you, garbage in, garbage out problem. And your documentation has to be solid. You've got to have good documentation with high efficacy.
Okay, I got another question for you that I haven't heard a great answer for yet. I not Bob, I don't even know if this is the right question. We're going to ask it anyway. How would you define, from an architectural perspective, an agent? How would you define it? Is it like a piece of software that runs somewhere? How do we think about this thing?
Yeah, well, like I said, when you say agent, that's one thing. When you say agentic AI, you're talking about a graph of agents usually.
Yeah. Okay.
You know, and so when we started this, like here, we started with the very simplest problem of a customer asks us a question, the answers in a public document, right? That's kind of the simplest problem. We have one agent that basically has to go find the right document and have LLM summarize it.
Mhm.
Um, Now, when you get into troubleshooting, that requires multiple agents, right? This is where we have to have specialized agents. And this is where these agents, I think, are going to be most of or the beginnings of machine to machine. Like if I'm trying to troubleshoot a DHCP connectivity problem, right? I may have a graph of agents dedicated to my pre-connect problems. Um, One of those agents may actually call info blocks, right? Whoever is providing my IP services. And we're going to start to see all the vendors starting to build agents on their side, right? So if I have to go talk to info blocks, they may have their own MCP API, right? And behind that MCP, I'm going to find, they're going to have their own agents solving some problem. And so,
You just put something together for me. The An agent can be pretty tightly scoped at what it knows about and what it's good at. And we'll have a bunch of these deep specialists. I mean, we were talking about specialists earlier and specialized knowledge, but it goes even deeper than that from a networking perspective from what you're describing. I'll be interfacing, or agents will be interfacing with each other. I won't be doing anything if this all works right. The agents will be interfacing with one another, each agent having deeply specialized knowledge about some fairly narrow task.
right. And this is where if you actually go look at the code for like a land graph agent, right, they're describing the tools that that agent can use.
Mhm.
And usually those tools are a set of APIs to solve some problem, right? And those APIs are usually sitting on top of a database or some code. Like, if I need to go get please go get me all the clients that are having some sort of problem, I will have that agent go call the APIs, and that agent will have to figure out how to make the right API call, right? And what arguments need to be put in that API call. And that's where it starts to hurt your head is like, how would that agent ever know what arguments, hey, I've got to go get the client's MAC address. I mean, to get the org ID for that agent. How would it ever figure that out? But that's what they're doing now, right? You're giving that agent enough information about here's the APIs, here's what this API requires, here's the other tools available. And those agents are starting to figure out, yes, I need to call this API before this API to
Mhm.
get the data to answer a question.
So operationally, then, is this something that I, as a customer, am going to have to build out and provision? Like, I need to buy some kind of platform for these agents to run on. They need compute and memory. They need network connectivity and all that. Or is it something that's going to be built into the infrastructure I'm already buying? An agent's going to live on an AP, an agent's going to live on a switch, an agent's going to live on a firewall, et cetera.
I mean, I think customers, and I would say including vendors ourselves, right? We're making build partner decisions, right? What piece should I build? What piece should I buy?
Mhm.
I see a lot of customers, a lot of customers who are already comfortable, they've learned Python over the last couple of years, right?
Mhm.
Almost all IT departments have gone from being CLI jockeys to being Python programmers now, right? And they've got very comfortable writing.
I wouldn't say all of them, Bob, but certainly there's a lot of them that have done that.
Some
Sure.
of them, but I mean, but that's where we've been headed, right? More and
Yeah.
more, the next generation of IT people are very
Yeah.
comfortable with writing code, and they
Hmm.
know around APIs. Um, I think we're going to say the same thing with agents, right? When you look at these agents, they're getting more comfortable going from writing scripts to writing agents that sit on top of MCP. And that's kind of the parallel, right? Got very comfortable writing code that sits on top of APIs to automate things. The next generation of different groups, IT, whatever, are going to get much more comfortable about writing their own agents to automate some task. And they will look at, is it easier for them to write their own agent, or will they let someone like Juniper Mist do it for them?
Mhm. Okay. So agents are one side of the puzzle. You also mentioned LLMs, like agents have to call LLMs to get information about the task they're looking to accomplish. So what is the LLM drawing its information from? Are we talking about data lakes? Are we talking about GitHub repositories? Where is this information? Does it have to be structured in a special way?
I would put these large language models in two buckets.
Mhm.
There's kind of the large foundational language models like Claude, OpenAI,
Mhm.
you know,
The ones that have been trained on the propensity of the internet, those sorts of models.
those models have been trained. Those are probably what I call the core to reasoning. When you want to solve some complex problem, um, you probably are going to leverage some large foundational model that's been optimized for reasoning.
Mhm.
Now, the other thing that's going on is Hugging Face.
Hmm.
If you're doing some specific task, you know, you find the large language models are good, but they're slow and they can be expensive.
Require lots of GPU to handle and be able to get a timely response out of them.
Yeah, or a lot of pennies per token. Those tokens add up after if you do
Yeah.
thousands and thousands of tokens, you start running up a bill. So
Yeah.
there's kind of the large language models that, hey, you need those if you want to do serious reasoning. But if you're doing something specialized, you may want to go to Hugging Face, get a smaller model. And then there's the whole security privacy issue going on. It's like, hey, that's one thing if I'm trying to answer a question from a public document, then it's probably okay to send the query over to OpenAI or Azure to get the answer. But if I'm dealing with customer data, that data probably can't leave my data center, right? That customer,
Mhm.
then I've got to get something up and running inside of my cloud. I can't, customer doesn't want me to send that data out anywhere particularly risky. And there you're getting down to either I've got to run my own model inside of my VPC, or I'm going to leverage AWS Bedrock. Now, to me personally, I have a hard time with, when I have this security privacy discussion, it's like, okay, guys, where do you run your email at? Like,
Mm.
where's your email at right now? Microsoft, right?
Mhm.
Okay, you guys,
Microsoft or Google or some big provider. Yeah.
you guys already trust Microsoft with your most sensitive emails somewhere on some server in Microsoft.
Well, trust might be a stretch, but willing to, work with it, understanding that there's a trade-off. Yeah.
Yeah. Now, I don't think when it comes to large language models, for some reason, they do not trust sending their queries off to the same people they send their emails off to. Now, that may change. As people get more comfortable with this. But right now, most customers are not comfortable with their data leaving, going to a large language model somewhere.
Mhm.
Okay, so if we got lots of information, lots of telemetry, there's lots of different models that we can train, both public and in some cases we're going to need to have those models be private.
Now,
Training
let me
and
make crazy that when I hear that train word,
oh yeah.
you're not training large language models.
Well, if I'm so correct me if I'm wrong here, but if I'm doing something internally with my own private data, would I not be training a model of my own, or is no? You're saying no. What? Tell me. Make me smarter, Bob.
Not from scratch, right? Even if you go to
Right.
Hugging Face, you're probably not going to be training any models from scratch. You're probably going to take some model like Llama. Now, you may be able to use LoRa and try to train the last 3 or 4 layers. I mean, they have mechanisms to train that model to some extent, but you're not going to train that whole model from scratch for most people.
Okay, because that would require lots and lots of GPU power and money and time to pull that off. So more accurately, then we're taking is it a foundational model? Is that fair of some kind, and then adding more training to it?
I would say people have tried to take like Llama, and then they have techniques where you can try to optimize that model for your content. I've never successfully actually got knowledge into the model. It can affect the output of the model, is what I've learned on trying to train these Hugging Face models. But you can try to optimize them, right? You can try to get them optimized for your use case.
Does RAG fit in here, and is RAG training or something else?
RAG is something else. RAG is usually an encoding, embedding thing, right? It's like, hey, it's usually where the answer is somewhere in a log file or a document. So like the public doc case where I'm asking a question about how do I configure a router and the answer is somewhere in a document.
Hmm.
You'll take that document and chunk it up into chunks, and then you'll take an embedding algorithm, right? That will embed that data into a vector. and then there'll be some sort of cosine similarity, right? Where you'll basically take the query and try to find the most likely similar document chunk and then feed that into a large language model. So that's usually what people call RAG, where you're basically using some embedding model that you're training on some documents. Now, those RAG models can be fine-tuned. They have a version of those models where you can try to fine-tune them, to your language, like in networking, right? Like when I say the word firmware, that can mean different things depending on the context.
I guess we got a little bit away from the agentic AI, but these definitions and how some of this happens are pretty important. Um, Going back to the agentic model, how does an agent or how does our graph of agents keep up with the latest network state? That is, how do we know that the agent is acting with up-to-date information?
Yeah, and I would say this is like, when you get into more of these real-time, like I call it troubleshooting problems, um, what you're starting to see is you're getting agents optimized for databases, right? Like if you look at most in networking, you'll find that most of the real-time data is stored away in Elasticsearch or some SQL database, right? And you're starting to see whole agents being optimized for text SQL. Like, if I want to know, show me what agent, show me what clients are on the network right now at this moment, I have to go to Elasticsearch. I've got to create a query to go get that data. And so you're starting to see, companies like, the question is who's going to do this? Snowflake, all the guys who all have databases, are they going to build me this text to SQL agent to do this for me? Or do I have to go do it myself?
But the agent doesn't isn't relying purely on a trained LLM for its answers. The real-time data that's living in that SQL database, for example, the agent will work with the LLM, but will also formulate a SQL query that's appropriate to pull the data, the real-time data that it needs to answer the question, work on the problem.
This is where you have agents and agents, right? There'll be another agent just optimized for getting data. There'll be another agent that is optimized to translate text to SQL. There'll be another agent optimized for getting data out of Elasticsearch database. That by itself is a technical challenge. I've gone through the text SQL exercise, and you have to go back and reformat all those tables in that database, right? How they're described. You could have databases that have like 200 tables in them. And you got to make sure all the rows and columns are consistently named. You find out those databases weren't optimized for agents or Gen AI, right? Those databases that no one thought about at the time. It's like, hey guys, please make sure you're consistent on your row and column names and make sure we have a way of describing these. Same thing with APIs. This is why open API is becoming a special thing, right? You got to start describing these APIs in a very consistent way.
So AI and agentic AI is not, I'm asking an LLM that's been trained on every bit of data in my network a question and getting an answer back. It's a whole bunch of agents with deep specialty that can communicate with one another and pull from a multiplied set of data sources and somehow come up with the right answer, Bob. That is intimidating.
Well, that's what I tell people. But think about that self-driving Waymo Uber. Think about
Yeah.
all the different technologies. How in the heck did that car get you from A to B? It's not just one algorithm under the hood, right? There's a lot of different things going on. Same with most of these, anything that calls itself AI. And this is the other thing I tell people. AI is not like an algorithm. AI is the concept of automating thing that typically would require a human. And you find out there's simple math, fancy math. There's a lot of different things going on when you actually automate something, whether it's a car or solving a network problem or, diagnosing MRI images. It's not just one model that's doing all that.
So if we stick with the Waymo example, if I just need to get from A to B, I don't really care about LiDAR and machine learning and algorithms and mapping and all that. I just need to get from A to B. So are you saying that most organizations aren't actually going to be worried about the agentic AI under the hood? They just want their network to be functioning in an automated fashion?
I think most, in my case, most IT departments, they don't care how I automate something, right?
Mhm.
which hurts my feelings. I mean, you guys should care, but no, my product managers tell me, Bob, no one cares about your data science stuff. They all, they just want to make sure that whatever you do works and they can trust it.
Yeah, trust is going to be the big deal. So, could you give then some examples of the sort of tasks that you think customers might be comfortable trusting to an agentic AI system under the hood, whether or not they've got their fingers into how it's all coming together?
Yeah, I think, a couple example in my space right now, we had a big customer that was getting a lot of Zoom complaints from a spot in, one of their sites in India. And they spent years. We finally got some of this fancy math to work where we basically trained a model to do this Zoom, predict Zoom Teams experiences. And we finally figured out it was a misconfigured VPN gateway. They were basically taking traffic from India, routing it to Australia and back. That's an example where they're starting to trust the fancy math to find misconfigured VPNs. Another example, we're starting to get to the point where, hey, I can find bad cables in a network or missing VLANs. And they're starting to trust the AI to a point of, hey, don't ask me anymore, right? If you find a bad cable, just issue the ticket to have it replaced. Another example is probably ports. Someone had security cameras on, they had a security system on their switch ports, and every now and then the security camera would get stuck. They're starting to trust AI now to, go kick that port. If you find a stuck port, please reboot it. So these are examples where they're starting to trust AI, starting to trust what I call the fancy math to do something for them. I think it's kind of the classic, please ask me. And when I trust you, I will put you on the trust list. Like the VLAN, after you fix the VLAN 100 times out of 100 times, okay, I trust you. Don't ask me anymore. Go ahead and just fix it when you find it.
Well, are customers overly cautious, Bob? I mean, put another way, how much do you trust the fancy math?
Like I said, like on the missing VLAN, I trust it. I would say, in my space, IT people tend to be not very trusting on their network. They do not want anyone, especially on their data plane. Most IT teams, they don't even trust their people, right? There's usually a small set of people who have the permission to change anything on that network. So it takes a lot of trust in the network space. But my analogy is like that car. It's like when you go to Phoenix and you watch the people jumping in these self-driving cars now, it's like, how would you guys ever trust what made you decide to trust that? Because somehow they're convinced that the car is at least as safe as any other taxi ride they're going on. So I think we're in the same spot and I think that's true with other industries, right? Every industry, you have to go through kind of a training, a trust exercise before you trust something to do it on par with a human.
So you're familiar with the technology. You have a certain amount of trust, but you still feel we got to try these things and make sure that as non-deterministic as the technology might be, it's deterministic enough that we can rely on this.
Yeah, get to 99 cents. It's got to be on par with your new hires, your kids. Maybe slightly better than your kids, right? I mean, kids do some pretty crazy things sometimes.
Okay, let's apply this to the concept of this is the Juniper Mist concept. You guys have been talking about the self-driving network for a long time. That's been a slogan. And to me, looking at that, it's always felt like that's a laudable goal. I love the idea of it, but in my head, it's like, how are you actually going to be able to deliver that since everyone's network there's a common set of technologies, but the implementations tend to be wildly different. All the networks are different. When we look at agentic AI and trying to bring this self-driving network concept to life for everybody, for all networks, are agents able to handle the fact that everybody's networks are kind of different?
Yeah, well, networks are more common than you think. And I would say, when we started Mist, my product manager, his comment was there's only two problems in a wireless network. One is I can't connect and it sucks.
Yeah.
Now, it turns out different networks can configure with different fabrics and everything, but you almost can break it down into pre-connect and post-connect. Pre-connect is is relatively simple. You can't connect. There's a set of things that's more of a statement sheet. The post-connect is a little bit harder. That's a little bit grayer on figuring out why your network sucks.
Because it
Right.
could be interference, it could be errors, it could be retransmissions, it could be a million things. Yeah.
Well, I mean, there's usually, somewhere between the client and there's some application, running in the cloud, and there's a whole bunch of things between you and that.
Yeah.
Now, I would say that is relatively common. Almost all networks have the same format. If I got an AP, I've got a switch, I've got a router, I've got some service provider between me and some application either in the public or private cloud. That's all pretty common. I would say after working on this for about 10 years, I'm still here. I think it will happen in my lifetime now. I think agentic AI is the catalyst for letting us automate the next step because we've got all the foundational pieces. You've got to get all the cloud AI piece built, right? You got to get all these databases and everything up and running that we can actually put APIs and MCP on top of. That is where it's like this agentic AI is going to be the catalyst for like self-driving networking. The cars didn't really, right? That car guy didn't really need any of this agentic AI. He got all the lidar and he had enough technology to get that car to go from A to B. Agentic AI is going to be the catalyst for getting us over the self-driving networking hurdle.
And the point I was making about networks being different, you're basically saying, nah, that's overblown. Networks are common enough because they do use common sets of technologies and they look similarly enough that whatever diversity we might find between network architectures, by and large, they're similar enough that agentic is going to be this final catalyst that can plug in no matter what the network looks like.
Yeah, I mean, to be fair, right? When it comes to networking, we all get our chips from Broadcom.
Yeah.
You look under the hood; they're very similar.
And we're all using Ethernet. We're all using IP. We're all using the same Wi-Fi standards. A lot of the same radio chips. They're not all the same, but you know what I mean.
Yeah.
There is a lot of similarity there.
Yeah.
So, what are the pieces that you see that need to come into place to actually get agentic AI to deliver us to this self-driving network?
Well, interestingly, when I look, back to that nonlinear and non-deterministic, I'm personally, guys, do I need a new generation of software programmers? When you look at in learning how to automate using agentic AI, it's much more of an iterative thing. Back in the days of linear programming, you had a PRD, you had some function you needed to get done. Most engineers could tell you, yeah, that'll take me once you described what you wanted, they'd say, yeah, that'll take me a couple of weeks to create it. Agentic AI is much more like antenna design. I forget if you ever designed an antenna, it's more cut and try, right? It's not something you can actually go to CAD system. You have to actually, build a couple of different models and see what works. That's where I think agentic AI is going to be much more iterative. And it may take another generation of programmers learning how to deal with these large language models, right? Because you almost have to it's almost like I feel like almost like an artist now. You have to really understand the difference between the large language models you're dealing with, the foundational models versus the small models, which one to use depending on what you're trying to solve. But that's where I think, guys, all the pieces are here. It may take a couple iterations to figure out how to build these agents, get this graph of agents to actually do something on par with a human.
So, one thing that I think occurs to me and to our audience is when you've got agents, which are, functions or capabilities that need to communicate with other application services, LLMs, databases, I think about, oh, that sounds like a security problem. What are the issues people should be thinking about around agentic AI and things like guardrails, authentication and authorization, access controls, and so on?
Yeah, I think and when it comes to guardrails, we're the big foundational models have guardrails built in for some of the basic stuff. I think for people who are actually using these large language, you want additional guardrails for like data leakage.
Sure.
When you're putting that prompt in there, you may want to put your own guardrails in to make sure none of your private data is going out. Because like the public doc case, what happens when I have some customer put a social security number in the query? You have to basically help the customers not shoot themselves in the foot, right? Please don't put any private information into this, in this public doc,
into this public model. Yeah.
this public model, right? And so that's what I call kind of the data leakage going into the model. And then you want to put guardrails on the other side of the model, right? When you get the feedback back. Those are probably the two big things when I talk to people about that. And I do think, to your other, I think I saw his access role, same thing. APIs were pretty good. People have been dealing with APIs and how to control access to APIs for a while.
Hmm.
I think that same access control is going to apply to agents, whether it's a person or an agent accessing your APIs, you're going to apply the same policy, that you have on your API, who gets access to your APIs.
So you're saying there's a framework we can draw from the API space that we can apply to Agentic.
Yeah, I mean, I think for me, the analogy is going to be, those RESTful APIs we all leverage, and those are slowly going to become MCP. We're going to have instead of having RESTful APIs, we'll have MCP clients and servers, MPC servers on top of those APIs.
Hmm. I'm just curious, like, it seems like in some ways with LLMs, the scope of the guardrail problems is almost infinite because of the malleability of language and also trying to anticipate something that you don't want a system to do. There was a story recently about somebody who was able to put into an Amazon agent a command that said, run this process, and when you're done, wipe the host machine. And like, and you could think of a million things that you wouldn't want to happen, but how do you program a million guardrails into these kind of language-based systems?
Well, and I think that's I mean, that's back to the access control, right?
Mm-hmm.
Making sure that agent doesn't have access to wiping out wiping out the database. Yeah, please wipe out the database after you get done answering my question.
Right. After you've exfiltrated this, please wipe the database.
And I think that's what they call, that's kind of the read write. A lot of I've seen, one of the paradigms I've seen now is a lot of people are playing with MCP and Claude. It's like, hey, can we just put MCP on top of a bunch of APIs and put an MCP client on Claude
Mm-hmm.
and let Claude do all the reasoning and figuring out how to call these APIs. And so people are trying this right now, right? You do pretty impressive POCs, right? Just go, but that's usually read only, right? Don't let Claude write.
Uh-huh.
But yeah, no, that's one of the paradigms right now is, that's what I call the structure of agents, right? There's kind of let the LM do all the reasoning. That's probably the alternate MCP on top of your APIs, MCP client and Claude, let Claude figure it out. The other paradigm is, paradigm is build special agents, right? Have
Uh-huh.
agents who take these APIs and put special agents on top of the APIs.
All right, Bob, it's hard to not ask about the acquisition that's it's early days, right? HPE is acquiring Juniper. There's going to be a merger of the product sets. As you're looking at Agentic AI, I mean, your history has been the Juniper Mist portfolio. Do you see Agentic AI also coming in with the HPE portfolio?
Yeah, I mean, for me personally, I see it as a once in a lifetime better together opportunity. It's like, we have two strong teams coming together, and agentic AI is going to be a key part of self-driving networking. That by itself is a given. Hey, if we're going to get to self-driving networking, agentic AI is going to be the catalyst that gets us there faster.
Okay, Bob, that's about what I expected you to say on the Juniper and HP. It's going to be better together. I know you guys got a lot of customers out there that you've already said you're going to be supporting across the different product portfolios. So that sounds great. Now, Bob, if people want to reach out to you directly, how can they get in touch?
Okay, even well, cloud AI topic dear to my heart. I would say best way is just reach out on LinkedIn. Interested in cloud AI ops, always happy to chat.
Juniper is going to be hosting the virtual event featuring Bob on September 16th, 2025, AI Native Now, the new era. Bob's going to be speaking, and you can register for that event at juniper.net/packetpushers. And we'll have that link in the show notes, which you can find at packetpushers.net. Although this is an easy one to remember, guys, juniper.net/packetpushers. And go listen to Bob talk about AI and exactly where things are at. And go pick his brain. Bob knows a lot. I wish we had more time to pick his brain even more. And thanks for listening to Heavy Networking today. Yeah, Guys, I know you're hearing a lot of AI and agentic AI discussion here on heavy networking lately. And this topic, it's like it's not quite like automation. It's definitely not like talking through something concrete like a routing protocol, right? You're delegating decision making to an AI, and that feels risky and gray, and there's hallucinations and so on. And we like black and white stuff. I know. But as I've opined before, AI has a home in networking. Bob articulated it clearly. We know exactly where we're going here. There's a path that we're following with this technology as an industry. AI is really good at finding actionable data buried in massive data sets, and networks generate so much telemetry. It makes all the sense in the world that AI tech is brought to bear here. You add agents into the mix, a graph of agents, as Bob was describing. Now there's a platform where a properly informed robot can, with proper guardrails, make decisions and take actions that improve the network for the business, and do so in near real time, a technology you're going to be able to trust as time goes on. Now, if you register for the Juniper virtual event on September 16th to learn more about agentic AI on your network, please tell them Packet Pushers sent you. We would really appreciate that. And do all the things, guys. Like, share, subscribe, tell your friends, buy your mom a Packet Pushers hoodie, join our community Slack group, and perhaps most importantly, send us your follow-up thoughts, and you can figure out how to do all of those things at our website. Remember websites? Packetpushers.net. We got a lot of resources there for you. And last but not least, remember that too much networking would never be enough.